All right, let's take a look at number 37. Right, a botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. The population of this species that the botanist expects to grow next year can be estimated from the number of plants this year, which is in this year, by the equation below. All right, so we have that equation. The constant K in this formula is the number of plants the environment is able to support. Okay, so that's the K value right there. Okay, so 37. According to the formula, what will be the number of plants 2 years from now if K equal to 4,000? Right, we answer to the nearest whole number. Okay, so we want to know the number of plants 2 years from now. If you look at this formula, what it does is, if you know the number for this year, right, we can plug it in for end this year for all, however we see end this year in the formula. And then we know K is 4,000, right? So the K value is already 4,000, we know that. So pretty much if you know the number for this year, we can plug in formula and we can solve for the number next year. Okay, but for this question, they want to know how many plants we have 2 years from now. Okay, so I had to use a formula to solve for the plan, but we had to use it 2 times. So not only we solve for the next year, but we had to solve for the year after that. Okay, so we're gonna do it 2 times. So let's start with the first number. Okay, so in next year. Okay, so that should equal to, okay, and here, let me just label. So this number that we got here, right, after we solve this, represent number for 1 year from now. Okay, so right now, right, how many plants do we have? Well, we have to go back up to the question and then we look for the number. There we have 3,000. That's how many plants we have currently. So this will be the end this year here. Okay, so we can plug in 3,000. Okay, and then we do plus 0.2 time in this year is 3,000. And then time in parentheses 1 minus in this year is 3,000 over K. Well, K is 4,000, right? So pretty much we can use the calculator here and solve this out. So we can start with, just start with this parentheses on the right. Okay, we can do 3,000 divided by 4,000. And then we do 1 minus that. Okay, so be 1 minus 0.75, right? Is 0.25. Okay, so we should get here 0.2 times 300 times 0.25. And we solve this out. 0.2 times 300 times 0.25. This is actually equal to 15. Right? So 3,000 plus 15 right there, which is, actually not 15, 150, because I think I missed a zero there. That's 3,000. That's 0.25. Okay, yeah, it should be 150. Okay, so we do 3,000 plus 150 is actually 3,150. Okay, so that should be the number that we have 1 year from now. That's 3,150. Right, so then to solve for 2 years from now, you see, we had to use the same formula, but then the end this year number will be the number that we just got, right? So the after the first year now, the 3,150, that would be like the current year, right? So to solve for a second year, we use the formula again, but for the end this year, we're gonna plug in this number, 3,150. Okay, so and let me just say that's the second year. That's what we're trying to solve. We'll plug in that this year, the current number now is 3,550, right? Plus everything else is the same setup, right? Except instead of 3,000, we're gonna do 3,150 times 1 minus, and this year is 3,150 over 4,000, right? K is a constant, so it'll stay the same, that won't change. Okay. And now we're just gonna solve this out. So we're starting with the last parentheses here, 3,150 divided by 4,000. And then we do 1 minus that. It should be, I got 0.2125 here. Right, and then let me bring up the other numbers. And then we do 3,150 plus 0.2 times 3,150 times 0.2125. We got 133.875. And we're just gonna add them together. Do 3 plus 3,150. Okay, add them together, we get 3,283.875. And this question, they said we had to round to the nearest whole number, so that's about 3,284. Okay, round to the nearest whole number, 3,284, and that will be our final answer for this question.